Welcome and thanks for joining us today to our next instantiation of our Coffee Talk Chat series. I'm Pete Baker, Vice President of the Developer Ecosystem Enabling Team here at Intel. And today we're going to talk to experts servicing the financial services field with MatLogica and Quantifi. So grab your beverage of choice and let's dive into today's discussion. Now today, with increasing demands on businesses to harness the value in data, IT resources are challenged to swiftly and cost-effectively manage increasingly complex data center needs. This is true whether you're detecting fraud, sequencing genomes, making product recommendations, or just optimizing your supply chain. Enabling smarter apps is just good for your bottom line. How do you overcome the complexity and greater intelligence, but still avoid breaking the bank? Well, it starts with lowering the barrier to adoption everywhere that computing takes place. And Intel is at the heart of standardizing and proliferating technology for over 50 years. And now we're at it again with artificial intelligence. Through a wide selection of productivity tools that span a lineup of general purpose to domain-specific technologies, all built on common standards. We at Intel like to think we'd like to make it easier, faster, and more cost-effective for everyone to infuse AI and analytics into apps from edge to cloud to client, unlocking invaluable insights in that process. But don't take my word for it. Let's learn from our guests, Dimitri from MatLogica and Sebastian from Quantifi, about how they're using our products from Intel to delight their customers. So gentlemen, welcome, and I'll ask you to introduce yourselves. Let's start with you, Dimitri.
Thank you, Pete. My name is Dmitry Golubentsov. I'm a founder of a company called MatLogica. MatLogica is formed around innovation in the automatic adjoint differentiation field, and I think we're achieving great results.
Oh, terrific. Welcome. And Seb, how about you?
My name is Sebastian Hahn, and I'm the artificial intelligence and machine learning lead for Quantifi. Quantifi is a fintech provider to global banks, investment managers, and corporations, and we help clients to leverage new technology to better trade and manage risk.
Terrific. Great choices for our discussion today. So let's start with the first question. Just help us understand a little bit on who your end users are and really how they're using this technology. Seb, let's start with you on that one.
Quantifi's clients are buy-side and sell-side institutions, including hedge funds, pension funds, sovereign wealth funds, and banks. And we also work with professional services firms and technology companies. Typical end users within those firms would be traders, portfolio managers, and risk managers. And one of the main challenges that we help these institutions with and that they face is that they need to calculate valuations and risk metrics such as sensitivities or stress tests on their portfolios. And they want to do that in a reasonable time frame. And for some calculations, the computations can be so complex that it can take a long time. And it becomes challenging to manage one's risk if the necessary risk data is not available quick enough.
Got it. And Dimitri, how about you?
Yes, so we are actually targeting slightly different audience. We're mostly offering our product to software developers and quantitative analysts within these financial institution firms. And this customer base is actually facing very challenging problem. They need to accommodate very demanding and intensive and very often complex business requirements and risk requirements. But at the same time, they are facing the situation that they need to take advantage of multi-core and parallel systems. So that means they need to change the way they develop software and sometimes need to refactor all the existing software to take full advantage of multi-core, NUMA-aware, vectorized systems. This is a very challenging problem, and we're trying to bridge this gap. We're trying to help them to do that. And the solution we offer is actually not limited to financial institutions. It's also applicable to other domains, such as HPC, weather modeling, and oil and gas.
Wow, fantastic. Seb, let's go back to you for the second question. Tell us a little bit about Quantifi. Give us a little context on the innovations that you're making when it comes to solving some of those problems you discussed for your users, and then where your collaboration with Intel comes into play there.
Sure. So at the core of our offering are portfolio management and risk systems that we sell to buy-side and sell-side firms, and these are often front-to-risk systems that cover many different aspects of the organization. But at the core of these offerings or underlying all of our offerings are our own proprietary models that help them to value derivatives and other products and calculate risk metrics on them. Now, the challenge that I mentioned earlier, that these complex portfolios can sometimes be hard to value and hard to analyze, is the area where we're working together with Intel on improving the performance of these models and achieving faster computations for clients so that they really can see their lives their risk as close as possible to real time. And the two ways in which we've recently worked with Intel that I would like to highlight is, on the one hand, on accelerating derivative valuation using AI and machine learning techniques, leveraging Intel's newest Ice Lake processors, where we've achieved valuation speedups of 700 times. And also, we've been working with Intel on accelerating XVA performance using Intel second-gen CPUs and Intel's Optane persistent memory to improve I/O and total performance. And both of these innovations empower our clients to conduct in-depth risk analysis more effectively.
I love to hear stories of 700x speedups. That's terrific. Dimitri, same question of you. Talk to us a little bit about MatLogica, what you're doing there, and our innovation work together.
Yes, so our innovation takes its roots from automatic adjoint differentiation and a very famous programming pattern called operator overloading. And we took this pattern from in this field and did something very different with it. We decided to use this pattern to extract all the calculations that executed by a regional user program and compile it at runtime into highly optimized, multi-thread safe, vectorized kernels executable on Intel CPUs. And this really gives a different perspective on how you execute HPC in modern software world. You can take your time and do object-oriented design, develop your software and make sure it's working correct, and don't really think about how fast it's going to run. Don't think what registers is going to be used for that, etc. So you don't really spend a lot of time on optimizing that. And then you execute your original program on one sample of data, create this massive valuation graph, and we convert this valuation graph into highly optimized kernels that can run in parallel and process many samples. So we take advantage of Intel AVX 512 instructions to do that. And this instruction set, after looking at this for many years now, it's a very good and future-proof instruction set to work with. I'd like to especially mention that just by increasing the number of CPU registers from 16 to 32, we also see a good boost in performance. And Intel, we're very happy to work with Intel engineers that can actually help us to optimize our software even further and to take advantage of all these low-level details Intel can offer.
That's terrific, Dimitri. Let me stick with you for just a second. If you could riff on that just a little more. So we're discussing about how you're really delighting your customers, speeding up analytics. Talk to us a little bit more about the MatLogica products and how they're intercepting some of those features. You mentioned AVX 512, you mentioned improved register size. Talk to us a little bit more about that, if you would.
Yes, sure. So our key product is AADC. It stands for Automatic Adjoint Differentiation Compiler. Although we say it's a compiler, it's actually something we execute at runtime. So it's not GTC, it's not your Clang. It's it's a library. This library allows you to convert a valuation graph, and this valuation graph can actually go from various sources. It can go from scripting languages such as Python. It can go from C++, object-oriented C++, and something that you didn't think of running as multi-thread environment, but now you can actually do that. But the focus here on our product was to make sure this conversion, the conversion from valuation graph into machine code, is done as fast as possible. And the idea here, you spend a little bit of time converting that, and after you did that, you can then process many samples our customers need to process. So be it Monte Carlo simulations, some historical analysis, what-if analysis, you name it. And the number of features we can take advantage in Intel hardware it's very impressive. AVX512 offers us a bit mask registers, which are very useful if you need to take care of branching, and also some new instructions such as gather and scatter, very useful for local vol simulations, for example. So these kind of things we can take advantage. And last but not least, I want to say that Sol started as a automatic differentiation. So we interested in computing derivatives of various programs, and these programs could be neural networks. So people can use our software to seamlessly differentiate through various business logic and machine learning models. So you can train your machine learning models that can take advantage and drive your business logic. This is the use case we can see very appealing to our users. And what else? Yeah, and just risk management is also very beneficial to this application. To take full advantage of algorithmic differentiation, you need a large memory space normally. And what I like about Intel CPUs these days, it can offer you multi-core systems, vectorized systems. So in terms of these processing engines, it has a very substantial number of them. And at the same time, you have access to very large memory banks. And this is very good for practical use.
You're clearly excited about the combination of our technology and yours. I love it. Seb, how about you? We heard from AdLogic about how they've been using Xeon Scalable and its features to enhance their end users' experience. Just help the audience a little bit more understand about how you're working with us together to leverage our AI portfolio of products and accelerators to delight your customers.
Yeah, as I mentioned, one of the challenges that our end users are facing is to be able to calculate valuation and risk metrics in a reasonable time frame. And many financial institutions actually don't know their risk in real time. And what we've done with Intel is we've taken some conventional finance models based on numerical integration and Monte Carlo techniques as they're used throughout the industry, and trained an artificial neural network on one of those models, and basically taught the network how to imitate the behavior of our conventional proprietary model. And we've then worked with Intel engineers at optimizing the performance of that neural network in terms of speed and accuracy. And in the end, using Intel's OpenVINO toolkit and also the Ice Lake processors, we achieved a speed up of 700 times, which really can make a massive difference in the life of a portfolio manager or trader, bringing calculations down from hours to seconds.
That's fantastic. Well, hey, guys, thank you both. This was just a fascinating conversation on really some cutting edge work. And it's a pleasure to hear about just the different ways you're working to deliver your products and solutions along with Xeon Scalable based platforms, really together right alongside you to deliver solutions that are going to work for your customers and ours. And this is just transformative in many of the businesses that we're servicing. So thanks to you both. Thanks to all of you folks watching us online. For more information, please check out our website at developer.intel.com, and cheers.